The problem states, in figure mass 1 equals 30 kilograms. That is a data, so we can actually abstract the data that mass 1 equals 30 kilograms, mass 2 equals 10 kilograms, the angle theta is 45 degrees. That's the angle of the incline, this angle. And we're being asked to determine the acceleration of the blocks and the tension of the string if the coefficient between the surface, the kinetic friction coefficient, is equal to 0.1. When we are talking about the kinetic friction, is at the surface M1 and M2, and at the surfaces M2 with the incline. We understand that mass 1 is the one which is going to win, such that the acceleration will be towards this direction. That's for block 1, but block 2 will have an acceleration towards which direction. We assume that the acceleration is the same and that the tension in the strings is exactly the same. Now we want to generate a free body diagram of each block. Let's take the two blocks. Block 1, for instance, we can actually define the x-axis towards the direction of the acceleration, such that the acceleration will be only projected in the x-axis. The y-axis is perpendicular to the acceleration. In that sense, we can actually state the forces that are acting there. The force normal, always perpendicular to the surface of contact, that's normal between block 1 and block 2. The tension always in the direction of the string. And the coefficient of friction, the force friction, which is coefficient times normal, always opposing motion. Last but not least, we have mass 1 times gravity. The angle which is going to describe this is going to be theta. That's the angle related, that's the angle which is from the y-axis. That's not the free body diagram. Actually, the free body diagram seems exactly the same, but without the figure. X, y, this is my origin 0, 0. The normal goes towards this direction, normal 1 with 2. Towards with direction, the tension, the friction. This friction is between 1 and 2 as well, and towards with this direction, mass 1 times gravity, describing here the angle theta. Many students want to know why this angle is theta. That's very simple. If we have the incline plane, this is a huge incline plane so that you can actually see it. And this is the angle theta. If the x-axis goes towards this direction and the y-axis goes towards this direction, the force F goes towards this direction. That's the gravitational force, always towards the center of Earth, such that this angle which is describing, the angle from x to the vector, is 90 minus theta. That's due to the fact that this is a rectangle triangle. Here then, this angle must be theta. The second free body diagram, well, is for mass 2. We can paint our axes once again, x and y. In this case, x is going to be positive x towards the direction of the acceleration. In this situation, we have a lot of forces. We have, for instance, first the mass times gravity, which goes towards this direction, mass 2 times gravity, with the angle theta once again from the y-axis. We have the tension towards the direction of the string. And we have now a normal force. This normal force is between the mass 2 and the incline plane. We call that a surface, for instance. We have as well two frictions. One is going to be the friction, kinetic friction between 1 and 2, and the other is going to be a kinetic friction to do with the surface. Both of them are opposing motion. We then have a normal force. This normal force goes downwards, and is the normal force which is being exerted 1 and 2, mass 1 and mass 2. Actually, this force normal 1 and 2 and this force normal 1 or 2, they are pairs action-reaction. These pairs action-reaction are applied to different objects, are opposite in sense, and have the same magnitude. That's exactly the same with this friction and this friction. This normal force has a reaction where it is in the inclined plane. These two tensions have two reactions, are not action-reaction actually. The reactions of these tensions are in the string. This friction with the surface has as well a reaction that's in the inclined plane, while the two weights or gravitational forces, the reactions are in Earth. Once we have generated the two free body diagrams, we can actually state the sum of forces in X and Y. A good free body diagram will help me to see the forces which are projected in X and the forces which are projected in Y. In the first one, when we state the sum of forces in X, we can actually see that the gravitational force has components X and Y. The component X is opposite to the angle theta, such that we can actually write mass 1 gravity sine of theta minus tension minus the friction 1, 2, and that's equal to mass 1 times acceleration. Remember, we're taking the acceleration positive. The sum of forces in Y will state normal 1 with 2 minus mass 1 gravity cosine of theta equals 0. Is the cosine of theta because the component Y of the gravitational force at this diagram is adjacent to the angle theta. In the other situation, the sum of forces in X is going to be equal to mass 2 times gravity sine of theta plus tension minus friction 1, 2 minus friction 2 to the surface equals mass 2 times acceleration. The sum of forces in Y, normal 2 with the surface minus normal 1 with the surface minus mass 2 times gravity cosine of theta equals 0. Let's just remember that the friction coefficient 1, 2 is going to be equal to the coefficient of kinetic friction times the normal 1, 2. That applies in this case and in this case. While the friction of the kinetic friction between block 2 and the surface is equal to kinetic friction times normal 2 to the surface. This applies only for this friction. Once you have the equations, you can actually conclude from this equation that normal 1 with block 2 is going to be equal to mass 1 gravity cosine of theta. You can obtain from this equation that normal 2 with the surface is going to be equal to normal 1, 2, which we already know is mass 1 gravity cosine of theta, plus mass 2 times gravity cosine of theta. Given that, the sum of forces in X is a system of two equations and two unknowns. The system of two equations and two unknowns have the unknowns tension and the unknowns acceleration. You can actually substitute values from here of mass, gravity, theta, to get the normal force, to get the friction force, and to have a system of two equations and two unknowns. With that, you can solve the system in order to have tension and acceleration.